Dear students, under the lecture series on complex analysis, we are solving problems under the topic Cauchy integral formula. In our previous video lecture, we have completed problem 1, and here we have problem 2. The question is to evaluate integral over c, z by z square minus 1, d is z, where c is the positively oriented circle, modulus of z is equal to 2. Now, in order to apply the Cauchy integral formula, we have to first rewrite this integral in the form that is used in Cauchy integral formula. So, if you see, the Cauchy integral formula says that integral over c f of z by z minus z naught dz is equal to 2 pi I f of z naught. Now, in order to apply this, we should first rewrite this given integral in this format. Now, if you compare with this, we see that in the denominator we have z square minus 1, but here we should have it as z minus z naught. Now, in order to bring that into that form, we are going to use the method of partial fraction for this. So, let us see that. That is the denominator is z square minus 1. So, what we are going to do, we are going to take this, that is 1 by z square minus 1 separately, and we are going to write it as z plus 1 multiplied with z minus 1. By using the formula, a square minus b square is equal to a plus b multiplied with a minus b. So, using this, we can write z square minus 1 as z plus 1 multiplied with z minus 1. Now, this can be splitted up by using partial fraction, that is a by z plus 1 plus b by z minus 1. So, this can be splitted up in this form. Now, we have to find the value of a and the value of b. So, for that, first we shall consider this. So, by the method of partial fraction, from this we can write 1 is equal to a multiplied with z minus 1 plus b multiplied with z plus 1. Now, in order to find the value of a and b, we have to put z is equal to 1 first. So, we will be getting 1 is equal to a multiplied with, if you put z as 1, 1 minus 1 will be 0, plus b multiplied with, if you put z as 1, 1 plus 1 is 2. So, from this 2b is equal to 1, and we obtain b to be equal to 1 by 2. In a similar way, in order to find a, we have to put z is equal to minus 1, because we need to make this as 0. So, therefore, 1 will be equal to a multiplied with, so if you put z as minus 1, we get minus 1 plus b multiplied with minus 1 plus 1 will be 0. So, from this we get 1 to be equal to minus 2a. So, minus 2a is equal to 1. So, from which we obtained a to be equal to minus 1 by 2. So, we have obtained the value of a and b. Now, we can substitute over here. So, after substitution, what we get is, we get 1 by z square minus 1 to be equal to. So, this is equal to a by z plus 1. A is minus 1 by 2. So, minus 1 by 2, 1 by z plus 1. And b is 1 by 2. So, plus 1 by 2 multiplied with 1 by z minus 1. We shall now substitute this in this integral. So, using this integral over c, z by z square minus 1 dz can be written as, so this will be equal to, we can split up that integral with these two. That is, first we can write it as integral over c, z by, instead of z square minus 1, we can have the first term. So, that will be this minus 1 by 2 I will take out. So, z by z plus 1, and then plus 1 by 2 integral over c. Now, the second one is z minus 1. So, it will be z by z minus 1 dz. So, rewriting this properly, it's equal to 1 by 2 integral over c. This term I will write first, z by z minus 1 dz. Since I have a negative sign here, so minus 1 by 2 integral over c, z by z plus 1 dz. Now, we have to check whether f of z is analytic. First is, so f of z is what? It is z for both the integrals. So, f of z is equal to z. which is of course a polynomial. That is, it is an algebraic function, which implies f of z is analytic inside and on C, because we know that every polynomial is analytic every inside and on C. Next is we have to check about the point z naught. Now if you consider the first integral, we have z minus 1 to be equal to z minus z naught. So from this we know that z naught is equal to 1. We know that the given circle is, what is the circle? It is modulus of z is equal to 2. So the given circle is modulus of z is equal to 2, which means center is at the origin 0 comma 0 and the radius of the circle is 2. So we have the circle with center 0 comma 0 and the radius as 2. So this z naught equal to 1. So modulus of z naught will be equal to modulus of 1, which is 1. And that this 1 is lesser than 2, of course, the value 2. So since it is lesser, it will lie inside the circle C. Therefore, z naught is equal to 1, lies inside C. This is the first one. Similarly, let us check for the second integral. Z plus 1 is equal to z minus z naught. So from this we see that on comparing z naught is equal to minus 1. Now what is modulus of z naught? Modulus of z naught will be equal to modulus of minus 1, which is equal to plus 1. Again this is lesser than 2 because it lies somewhere inside the circle. Therefore z naught equal to minus 1 lies inside C. So if you see, in both the cases z naught lies inside C. So therefore we can apply the Cauchy integral formula for both the integrals. So therefore I will write the first integral over C z by z minus 1 dz. This is the first integral. So that will be equal to 2 pi I multiplied with f of 1. So that is equal to 2 pi I. We know that f of z is equal to z. So in this, if you substitute z as 1, we get the answer to be 1. So 2 pi I multiplied with 1, which is 2 pi I. So this is the first integral. Now next, integral over C z by z plus 1 dz, which is the second integral. And by applying the Cauchy integral formula, it will be 2 pi I f of minus 1. So that's equal to 2 pi I f of minus 1. So if you put z as minus 1, you get it to be equal to minus 1. So this is minus 1, that's equal to minus 2 pi I. So this is the second integral. Now we shall take and substitute these two integrals over here. That is here. We know that integral over C z by z squared minus 1 dz is equal to, this is the first integral and second integral. Both we have evaluated. So taking and substituting, what do we get? We get here to be, that is integral over C z by z square minus 1 dz is equal to, first we have this, that is 1 by 2 multiplied with the first integral. So what is that? 1 by 2 multiplied with the first integral is 2 pi I. So 2 pi I. And then we have minus 1 by 2 multiplied with the second integral. So minus 1 by 2 multiplied with the second integral we have obtained to be minus 2 pi I. So if you see, this 2 and 2 gets cancelled and these 2 also get cancelled, and we obtain, here it is pi I, and then minus into minus becomes plus pi I, and therefore the value of the integral is obtained to be equal to 2 pi I. Hence we have evaluated integral over C z by z square minus 1 dz to be equal to 2 pi I. So I hope you would have understood how to evaluate the integral using Cauchy integral formula. Kindly follow the upcoming video lectures for more problems under this topic. Thank you.